Alright guys, so I was just thinking about um, the computer's AI for various projects, and I just want to go over what I came up with. Um, I have some real breakthroughs here. So, let me just go through it. Alright, so my first experience with navigation from an AI perspective was in the realm of video game botting. And I would basically um, use a waypoint system of coordinates and have the character follow the waypoints. So he would turn to face the next waypoint and run toward it, and then turn to face the following waypoint once he reached that one and run toward it, and so on. And so he could follow these little breadcrumbs. Think of like Pac-Man following the little dots that he has to eat. Okay, so that system was really powerful and excellent, and it worked well. Um, but I realized someday I'm going to need to, or want to, navigate without a coordinate system. That's really the next level of artificial intelligence, interacting with a three-dimensional world or a two-dimensional world. Now, that's a lot harder, because now instead of just being able to obtain coordinates from a game through whatever means, you're obtaining them, and then have your character's coordinates known, and then have those coordinates move to the next nearest coordinate, and so on. Now you're actually having to do a lot more computer vision type of stuff. And I really broke that down this time, thinking about how I'd really pull that off. And it's important for me to be able to do that because it's necessary for self-driving cars, it's necessary for humanoid robots, for drones. It's necessary if you want to be able to have your bot learn to play new games for video game botting. It's necessary for like a robot lawnmower. It's necessary for, I don't know, any type of robots. Okay. So, um, actually, it's also necessary. Well, not necessary, but it's also useful uh, for the purpose of having a machine be able to intelligently watch video footage to learn from what's going on in a video. So, in other words, having the machine be able to watch a YouTube video and learn how to do a task from that video and then carry out a task. That could lead us to general AI. I mean, really, if a machine can learn how to do tasks by researching videos, that could be game changing. Um, who knows? I mean, if you could teach machine to program, to computer program, that could be game changing. But I'm not I think it can like mime what it sees in videos and figure out how to interact with three-dimensional objects and interact with the world around it. But it might be a completely different thing to actually have it use any type of logic. It would just seem like it's using logic, but like in the case of coding, how is it going to logically put things together? So that would be a taller order, but this is at least getting us down the right path to get toward a really advanced AI. Okay, so let me just go through what I came up with. So for this, you can use an advanced vision system that is based on movement in addition to edge detection and use of edge detection to generate outlines and blobs. So basically, this is how I've heard computer vision is being done. Basically, the first step is to look at a scene. Well, no, the first step is to take a scene, to scale it down, look at it, and detect where color changes or shade variations are that are somewhat severe and draw lines there, and so detect edges of where one object stops and another object begins, or a possible object change. It could just be somebody's belt that creates a line, but that's still an edge between their stomach and their legs, and so on. And eventually, you use all the edges and other contextual information in what you're looking at to determine objects and determine foreground from background and determine patterns and identify objects within the scene. And all that's important in order to visually understand things you're looking at in an environment. And that's necessary for navigation, like a human navigates an environment. You have to understand what you're looking at. And if you go into a funny house, by the way, you'll be running into mirrors, running into things, because it screws with your ability to visually understand what you're looking at. It's confusing. So even humans aren't perfect in this regard, so that's good. And machines actually can be better than us in that regard then, because they can use things in the real world anyways, such as, well, we've got stereoscopic vision for depth perception cues, but a machine would have something better. They would have a LiDAR, so actually listening to echoes of not necessarily radio waves. LiDAR, I believe, is laser reflections off objects to determine distance. And you've got sonar, which is actual sound reflections being captured. And so those types of devices can help a machine navigate effortlessly in an environment where there's no light. And that could be really advantageous to supplement vision systems in machines so that they can navigate in darkness and fog, etc., which is really useful for self-driving cars and stuff like that. Okay, so anyways, I'm making a YouTube video right now, but this is just as much for chat, and we can still discuss. I'm not talking to anybody. I'm talking out loud, teaching future students who actually care about what I have to say and my breakthroughs in artificial intelligence. And a lot of it comes down to understanding a plan, and then executing that in code is the next step. But I have to understand how the machines are going to process things, how they're going to learn, how they're going to act. And so it's very important for me to do these types of sessions to document my breakthroughs mentally and understanding these concepts which can be applied to software. Okay, because you guys think I'm a phony, you think I'm just talking nonsense, but I'm not a phony. Alright, so anyways, back to what I was saying. Machines in real life can have LiDAR and radar to aid them in depth perception cues. But fortunately, you can gain a lot from a video or from a VR experience or from looking at somebody playing a game or playing a game itself in the case of a bot. It can gain a lot of information about its environment through some tricks. So after it's done all the edge detection and blobs, it still needs more information to know what it's looking at. Now, some of those blobs and edge detections, it can actually look up. Like, if it sees, like, a small thing here, and then two things coming down, and then a rectangular thing coming vertical, and then two more rectangular things. Oh, look, that's a stick man. That's the shape of a human. All the proportions match a human. So then it could identify an object as being a human. But it might be a poster of a human. So it would need to explore further, but it can get some ideas based on looking up things based on various proportions and characteristics. It can look into that and be able to identify humanoid or car or tree or bush. Or if it sees a large rectangular shape and it's able to determine the size of it is approximately 7 feet tall by 3.5 feet wide, it can say, that's a door. So then it could know, like, oh, maybe I can walk through that. So it can get some ideas of contextual clues of its surroundings and what can be done within these surroundings based upon proportional things and stuff like that. So being able to identify edge detection, outlines, and blobs is very important to get it down the right path. Okay, so anyways, these can be cross-referenced with a database of detected objects to determine visually what an object is on the screens. Okay, so we went through that. Of course, then the next step is to scale down the image to reduce pixel processing. Yes, so basically an image has thousands and thousands of pixels if it's like the size of your desktop screen. It's, what is it, 1280 by 720 or whatever, or let's just say 600 by 800 if it's a low resolution monitor. That's 600 times 800. That's 48,000 pixels, and you have to go through each one. It's just too much. So what you do is you scale it down to a much smaller picture, and then it can go through the pixels and do all the edge detection, blob detection, etc. on that smaller thing. And if it wants to zoom in on something a little further to help it detect that object, it can then focus on a portion of that screenshot and do all the pixel processing within that. But it doesn't want to just scan the whole thing, every pixel, and try to do anything, because that's too slow. based on speeds of processors. It's just too slow. Now, parallel processing can help. Maybe assign a different parallel processor one line and another processor another line, or another computer. It can communicate through serial communications, bit banging, sending it another line of pixels, and they can all go through various lines and split up the job with actual separate machines, if that would be preferential depending on the use case. So there are ways to break down and split up workloads to speed it up. But it's always, as a general rule of thumb, good to just scale down first. Okay, so anyways, alright, so a movement system is a trick to help to identify objects further. Specifically, alright, so we've already got the blobs and edge detection, but then if we want to know if an object is close or far to get some idea of scale, it could be a giant right in front of us. No, if it's right in front of us, if you saw a human right in front of you, it looked really big. So you could say, oh, that's a giant. That's really far away. Or it could be a normal sized person really close. So you want to know which of the two it is. And in order to determine that, you look a little to the left and look a little to the right, and that object will move across your frame of view differently depending on its distance. If it's a giant 100 yards away and you look left and right, it's not going to move much. But if it's right in front of you and you look left and right, it's going to move vastly across your plane of view. So being able to turn your head left and right to look around, which you can do in a game, you can do in a lot of circumstances, will give you a lot of help in determining distance of objects from you. And that will give a lot of clues as to the size of the objects. And that's without any depth perception tricks such as stereoscopic vision, which wouldn't be available if you're looking at a game world, or if you don't have a second camera, or you're looking at a video perhaps. Although video you couldn't turn your head either, so that'd be really hard, but this is still a good trick. And in a video sometimes you'll notice the person in the video moves left and right. The camera just moves, turns. So that can help to determine these types of things based on the camera turning. So that would be helpful. So how much the objects move as you turn is great. If an object in the video is moving, it is in front of other objects. If as it moves, those objects become disappeared. So if a person walks by you, and as they walk by, you don't see the things behind them, then you just got a clue as to these things behind them being further than they are. And if you are able to detect it's a person, and estimate based on maybe the size of the belt buckle or the proportions of the person, you can estimate if it's a particularly small person or a particularly big person. You can estimate then a height for a person based on average heights and so on. And then if you know the height of that person, then based on how much of that person you see, based on the width of your field of view, you can determine roughly how far away from you they are. And so that's giving you distance and a measurement tool to measure other things in the environment based on the size of that person. If the person's like a ruler, then you know the size of that. You can measure it against other things near that person. So there are lots of ways you can take contextual cues based upon being able to identify objects. So that helps a lot in order to gain measurement information. Oh, and then being able to measure all the objects, you can then measure heights of objects off the ground, and then based on measuring the height of the object, you can determine whether you can step over that object if you're a game character looking to go past an object, the question is, well, do I need to go around it or can I go over it? So if it's only 6 inches off the ground in a game, your game character can mostly just run over it. So it'd be like a small rock or a small bush. You'd know that the game character could run over it. So, or if you got stuck on it, you would be able to make a mental note for that game. Okay, objects of this height actually do create a collision problem, so I need to go around objects of that height. So you could try to make rules based on that. And in real life, you could actually do the same for like a real humanoid robot in a real world. Okay, so that will help with determine whether we need to navigate around an object or can just go right over it. Okay, so also another trick to determining objects, even if we don't know what they are and we're able to just generate all these blobs, but a lot of the blobs could just be patterns like a sidewalk. A sidewalk or a trail is not the same as a tree. So how do we determine that? Well, a trail might be meandering and getting smaller as it moves further away, but so could a tree. It could seem like a trail. But a good way to determine object versus ground is just having some database of suggested examples of what a ground looks like. And so like a typical ground might just be grass or pavement or foliage or a road with road lines or a sidewalk and more grass or asphalt or wheat fields or leaves. And by being able to identify 20 or 30 different looks for a ground, it'd be pretty easy to identify the ground pretty much across the board anywhere in the world at that point, or sand, like in the case of a desert. So being able to identify the ground is important because then it'd be easy to identify things that don't look like ground. And by knowing what's ground and what's not ground, that can give clues as to, oh, then this might be an object. And then we could go to town and try to identify that object. So just being able to rule out known things from just a random scene to determine what's not known, and then focus our attention on determining, okay, is that not known thing something we need to be focused on? Can we look? Okay, so you can see something that's not known, pull out a picture of that, Google image search it. Oh yeah, it can use Google image search. A bot certainly can. Use Google image search to image lookup, and then try to identify the object through image lookup. If that fails, it can put that object in a folder for me, the programmer, to eventually identify. So unidentified objects, over time I can start identifying these, and there's only so many objects in the world, and most of the time he'll probably be able to identify it himself through image lookup. So I would then begin to identify more and more things, and eventually my robots would know what everything is. Also, if it is a known object, it can download a free 3D model of that object by name after it determines, like let's say it sees an object, it's not sure what it is, Google image searches it, it's a car. And then it's like, okay, I know it's a car, but I'm looking at it from this angle. I want to know what it looks like from different angles in order to create a three-dimensional model of it, and then know how to interact with it based on what it looks like from every angle, and determine a lot of measurements and things like that. And so it could actually go and download a 3D model of a car, or go to a 3D website with the model viewer and click on the model viewer and drag the mouse in order to spin the model and look at it from every angle. And in that way, it can start to generate databases of models from front, top, three-quarter, side, back, etc. to know what a model looks like from every angle. And in doing that, it can gain a lot more information about its environment than just flat images. It can create three-dimensionality and predictive models of what things would look like from other points of view, which is important. For example, and here's an example of how that's important. For a VR system, you would want it to be able to take a game scene and convert that to stereoscopic vision. Stereoscopic vision means you have one eye here and one eye here. I see a little bit more of the left side of things with this eye, a little bit more of the right side of things with this eye. So in order to create an accurate stereoscopic model for a VR headset, I need to render a perspective of the scene from the left and a perspective from the right in order to give depth perception different scenes to different eyes for the headset. It actually shows a different image to each eye, which gives the illusion of depth, which is what makes VR so incredible as an immersion experience. In order to convert a game scene to stereoscopic vision, it needs to render the scene from two different angles. In order to do that, it needs to be able to create predictive models of what all the objects are in the scene it's looking at will look like from different angles. So in order to do that, it will need to know what every three-dimensional object looks like from different angles, and then be able to do predictive rendering with textures of the objects from every different angle, so that it can look at a scene, create a three-dimensional model of every object in the scene, and then rotate the scene, and you can see the scene from every angle. That is when you know your vision system is really solid, when it can actually produce a 3D world of any picture it looks at. And that's how you can test the quality of your vision systems, to verify that they really know their crap and they're not just kind of winging it. Like, you don't want a self-driving car to just be able to follow between the lines on a road. You want it to create a whole map of its environment in order to navigate through it. So it needs to know the sizes of everything it's looking at and be able to create 3D meshes of everything it's looking at. And then you can travel around that mesh in order to do path planning and not just be reacting all the time, but actually plan in advance based on modeling its whole environment and then knowing how to path through it predictively. Especially for high-speed applications, you need to be able to know, okay, I see a building there, it's an obstacle, but then actually predict how big that is from perspectives that it can't see, to know if it turns the corner, is it going to hit the back side of that building or not, for example. Okay. Okay, knowing what the ground looks like is important for being able to detect sloping hills and stuff. So if you're running up to a mountain or a steep hill, it might look like an object because it's taking up your whole field of view, and you have to look up to get past it. But that's not actually an object, it's just the ground that's sloping up. So being able to identify what what a ground is will help you to know, okay, that's just the ground, but we're just going upward now. So I think that's important. And that would be a confusing challenge for a vision system, like to identify a hill or mountain. As far as, like, normally ground is flat and then objects come off of that vertically. Hills and mountains suddenly go up, so it's like, where'd the sky go? Where's the horizon line? So that could throw it off, so it needs to be able to identify those types of weird exceptions. And then it needs to be able to know, based on the slope of the hill, can I actually walk up that or not? Or can I climb it? How are my climbing skills? So in the case of a game character, it can have some idea of, can I go up this hill or is it too steep for me? In the case of a real life robot, it would be, or a car, it would be like, is this too steep for my car, etc. So this is important for it to identify slopes. We have already gone over doorways and basic objects and identifying whether we can walk over them or they're actual obstacles or we can walk through them. So that's important to know. Alright, so being able to create a video game bot that can actually beat any game is kind of a goal. I think games are a great way to test because it's harder to send real life robots out into the world. Games are virtual worlds. There's tons of them. Having your bot be able to go out and play games and learn from games, I think is great. We've gone over the VR application, being able to translate flat images into stereoscopic renderings is great for porting AAA games into a VR system, so you can play AAA games and actually feel like you're inside the game physically in real life based on VR glasses. That's what VR does. And the benefit to that would be we don't have to do any memory reading and downloading of all the 3D models in the game. It would be able to just automatically translate what it's seeing to a VR setup based on predictive modeling of what all the objects look like from different angles in order to create the two different renderings, one for each eye. And so that would get around any obstacles where the game makers could potentially say, you're copying our game, you're downloading models and stuff to create your VR world, copy of our game. Copying our game equals copyright infringement. Gotcha. See you in court. Although I've gone over in my other video how I think game companies would be totally cool of somebody creating a port of their game to making it a VR experience. I think they would probably pay you, or maybe they'd want to cut though. I mean, I don't know. I don't know how that would work, but I just don't think any game maker would be mad when you're basically putting their game on another platform for people to enjoy and they'll get more sales. It'd be different if you're going to try to sell their game or take advantage of their players in any way, but if you're just following all the rules and just creating a new platform for people to play the game on, I mean, I guess that's the equivalent of, say, I don't know, buying a Super Nintendo cartridge, or no, creating another game system than Super Nintendo that works with Super Nintendo cartridges, except the company Nintendo would be mad because they'd be like, we own those game cartridges, you can't create another system that can play them. Except we're not using a cartridge, or we're not using a game that's only possible to be played on one machine. We're talking about PC games. And PC games, who would be mad? Only the game maker, but the game maker, seeing that their game can be played on other systems than PC, such as VR, they'd get more sales. The bottom line is money. If they get more sales, you should be fine legally. So I think it's fine regardless, but anything I can do to make it less likely to be an issue just makes it a little safer for me from a legal perspective. So I think if I created a VR system that didn't have to copy anything, then that takes away some ammunition for them to possibly do a lawsuit ever. Anyways, alright, we talked about if an object we can't identify in any way, we can create a folder to manually identify myself at some later date. And by me going through that folder and identifying objects, the bot will become leaps and bounds more accurate with its vision system because it will start to know what all these objects are. And once I verbally identify it, like that's a car, then it can look up cars and download 3D models of cars in order to know what cars look like from every angle. And then it will always be able to identify cars. So that's just a really powerful tool. Any type of AI learning system, oftentimes a lot of data has to have a human look at it and identify things. And then once a human has identified all the objects many times, then the robot can start to identify those objects based upon neural networks to start to know what it's looking at. And we can also have our bot incidentally use neural networks and just start looking up random stuff on Google image search and being able to identify objects randomly, or it can try to identify them as it comes across them in its game application or in its real life examples. But I think the more it can know in advance, the better. So that rather than see a bird and be like, Google image search this image of a bird, and then Google's like, that's a bird, and then it's like, okay, and then it looks up a million pictures of birds, and it gets an idea of what all birds look like, and it creates a neural network modeling of a bird and all the features of a bird and how to visually detect a bird and all the outlines of birds. I think that if it just looked up bird in advance, it would be better off. So maybe it should just be given a list of objects: birds, cars, utensils, humanoids, animals, just like kind of higher level objects, and then just look up lists, like list of animals it could Google, and then get a whole list, and then go through the whole list and search up all that stuff in Google image search and download models of each animal, and then be able to identify all the different animals, be able to identify all the different humanoids. And so I think that that would be a great way for it to just go ham on the internet, just learning how to identify millions of things. And then when it actually gets used in real life, it would just have this tremendous library that it can pull from to identify anything it comes across. So that would make it less likely to come to me and be like, hey, can you tell me what this is? And I'll be like, oh, that's a bird laying on its side. And it'd be like, oh, because it was hard to Google image search a bird laying on its side. Normally, Google image searches only work when it shows a bird in flight, for example, or standing up. And laying on its side, it just looks like a blob. So, like, if it had already done extensive research on birds and downloaded 3D models on birds and looked at them from every angle, then if it saw a bird on its side and it already knew what a bird laying on its side looks like because it did every angle identifications of that model by downloading a 3D model of it, then it wouldn't have asked me. It would have just known that's a bird laying on its side. So that will make it a lot more accurate of a vision system to have it just go out and just research like crazy every different type of object and create a vast library to pull from to help it in identification. Alright, so we've gone over this, just testing its vision system. We just show it scenes and challenge it to create 3D models of the entire scene, including all objects within the scene, identify every object in the scene, and then rotate us around from a perspective view of the entire scene, walking us through the scene and navigating through it. And another benefit to it doing well with tests like that, looking at any random scene, could be pulled from a movie, could be pulled from real life video footage, whatever, or can be pulled from just any random picture, is if it can take a picture or a movie and create a whole scene, realistic, complete with models, meshes, render, and everything, then think of how easy it would be to make a video game. I could have an AI-generated video game world. All I'd have to do is be told or figure out, okay, we want to create inner city based zombie game. Okay, and it just look up ghetto of a city and then stop listening. Stop listening. And after it looks that up, it will look up pictures or find a video of that, and then it would just look at all the buildings, the sidewalks, the people walking, and create a three-dimensional world of that and animate it all. And then, boom, your whole game is made. That's it. And then if it's like, okay, this building has a door and it identifies a door, and it's like, okay, well, people and characters can walk through a door. So then it needs to go in through that door and create a model of what the inside of the building looks like. So then it Googles inside of a building. or inside of an inner city building, and then it watches a video of somebody walking throughout a building, or several images and videos of insides of buildings, then it can generate a model of an inside of a building, and now you've got another portion of your level for the character to explore in the game. And all you would have to do as a game developer then is just tell it, like, no, like change the decorating or the inside of this room to be white or whatever, and it just change it. Like, you could just tweak it a little bit if you feel like changing the direction artistically a little bit, and then boom. I mean, literally, it can just, the game would just create itself. So that's the way to go for as a game dev. Forget like downloading free 3D models. Forget creating 3D models of every single object in a game and creating entire worlds by hand. You need a big team to do that, or years and years and years. But with advanced artificial intelligence, which I already have to make for all of my projects to work, I'll be able to snap my finger and make a video game. So yeah, my game is going to be generated the same way that Notch generated Minecraft worlds based on algorithms, and they're endless worlds. And I could have my games do the same. Except instead of little fake pixelized worlds, it would create actual cities and suburbs and deserts and forests. Whatever you want, it could create. And it could also auto-generate the plot, the quests, or the tasks you have to do, the goals, etc. And the game could just make itself. Period. Alright, we've already talked about animating using physics. So we'd create physics of objects and weights of objects and animate how those objects would move based on physical rules of the world of physics, so that we could create dynamic AI based animations. So we wouldn't have to animate anything ever. The AI would animate everything automatically just by observing objects and how they move in video footage, and then emulating that and using real life or simulated physics and rules such as momentum and gravity and the strength of all the various muscles, and it would actually be able to just generate walking gaits and running and everything else for humanoids and cars just rolling, and they'd have to stop according to the laws of physics and friction and the speed with which a car can stop, maximum speeds, and it can just do all that automatically. I mean, pretty much animals, humanoids, vehicles. I mean, that's most of what moves in a game. Maybe objects blowing, like tumbleweed, paper blowing, a can rolling. It just wouldn't be too hard, I don't think, to do all the animations automatically. But I think it will be really powerful to use 3D model viewers on 3D websites where you can download free 3D models. I think that using that to create models of, thousands or hundreds of thousands of different animals, objects, humans, etc., from every vantage point, that will be game changing for giving the bot the ability to render and create models of things, as well as predictive models. I can look at the side of a person and create a predictive model of what the front of his face looks like and the other side of him looks like that I can't see. Children struggle with that. They see something, and then you put your hand in front of it, and they don't know what this is. They just see these fingertips, they see the wrist, but they don't know what the rest of the hand looks like if I cover it. A child just can't do that. So I want my bot to be better than a child. It will look at the fingers and the wrist and be able to create a 3D model of what the rest looks like based on its knowledge of what a hand looks like, for example. So that type of thing is really important for it to just know everything going on, so that if its vision is obscured by, for example, a semi-truck driving across the road in front of it, it's still going to know what's behind it because it drew a whole model of its environment and it predicts what's behind things. Okay, another hint or important thing for it to do to create predictive models is to look at a scene, take a snapshot, half a second later take another snapshot. Anything that moved in that scene, first of all, that tells us it's most likely not our background. It's most likely an object, which could be an obstacle, could be something relevant. Could be a car moving, could be a person walking, could be a bird flying, could be an animal, could be whatever thing that moves. And based upon one frame and the next, seeing the speed at which it moves, it would then be able to create a predictive model for the next frame of where it's going to move, and so on. And it would try to predict the direction, the heading, and the speed of all the models and where they're going to be at X point in time. So if it's walking down a sidewalk or walking through a crowded room with people walking back and forth or walking through just, chaos, it would have to look at the speed and direction of everybody moving and using predictive models be able to chart a path through that without running into people. And that's hard. So you really need to be able to see, okay, this person's facing this way and they're walking at this speed. And it would know if I'm at this point in time, they're going to hit me. So it would know to go behind them. But if it knows its own speed, it's going fast enough, and it will be able to get past that point where they're going to be in half a millisecond or half a second, then it could go for it. And that's exactly what you need to know, like when you cross the road. You look both ways, you see the speed of a car, you create a predictive model in your mind of where the car is going to be by the time you're in the center of that road. And if you're going to be where it's going to be, when it's going to be there, you're getting hit. So it's important to create predictive models to be able to interact with the three-dimensional world. Very important. Otherwise, you're going to be crashing all the time into things. And that could mean, in the self-driving car, your passengers get killed. It could mean running somebody over. You name it. So predicting what every object is doing and where it's going to be, and then making decisions based on that. If this deer is running out into the road, are you going to just hit the deer, or are you going to veer off and hit the semi-truck, or are you going to veer off and go off the cliff? Well, if those are my three options, I'm going to freaking hit that deer. So it needs to also create a predictive model of the amount of damage that's going to be inflicted on the passengers, who to kill. If there's 10 people standing here, one person standing in the middle of the road, 10 people standing here, you're driving at a high speed, you don't have time to brake, well, I'm going to hit the one person rather than hit the 10 over here or 10 over there. I'm going to try to minimize damage. So it will need to make decisions, in some cases, God forbid, of how to minimize loss of life. And that's what makes a really good AI for self-driving cars, or for anything where something's going to get hit. Or let's say there's a small child standing here, an adult standing here, and it's a humanoid walking. And it doesn't have time to stop. It's moving at a high speed. It just turned a corner. There are these people in the way. Is it going to crash into the child or crash into the adult? Is the adult paying attention? Is there a cliff right behind the adult where if it crashes into them, they're falling off the cliff? Can it hit the child without the child being killed or the adult being killed? It needs to ask these questions to be able to create predictive models of what's going to happen and what's going to kill somebody or cause the least injury or pain and suffering. Probably placing more priority in not hurting the child, because if it hurts a child, it's going to get in more trouble than if it hurts an adult. So it'd be more likely to hurt the adult. But it'd prefer to hurt a man over a woman, because hurting a woman will get it more in trouble socially than hurting a man. It needs to make tons of decisions based upon societal expectations and all kinds of stuff. So there's a lot that needs to be gone through very quickly, mind you, in terms of rules of what's politically correct, in terms of when I am going to mess up, I'm about to hit somebody, who do I hit and how? And also, if it can, it would try to crash into, let's say, the man. If there are a woman and child to choose from, it's going to crash into the man, provided that that's not going to kill the man, hopefully. And then it'd grab the back of his head and put its other arm down to try to break the fall. So it would try to coddle the person it's about to crash into and prevent them from getting injured the best it can, possibly even whipping them around and falling itself and having the person fall onto them in order to break their fall with its own body, sacrificing itself to protect the person. So all these things need to be modeled predictively. Several different versions of the collisions need to be animated predictively in the mind of the robot before it chooses the best scenario where the least damage has gone through. So kind of like the movie, I believe it's called Next with Nicolas Cage, where he walks through a room and gets shot. So then he goes back in time and walks through a room and takes a left step and he doesn't get shot. And then he's like, okay, I'm going to choose that path. And so he's able to like replay the future many times in his mind and then choose the best path based on predictive or like trial and error. My robot can do the same. It can actually play out different scenarios at very high speeds and choose the scenario with the best outcome. And then it will actually act on that scenario. So it needs to be able to do this very quickly. And that will require a lot of parallel processing, a lot of machines running a lot of scenario simulations at the same time. So if there's a multi-core processor, it will have assigned various cores to run these simulations. If the main computer is handling too much other stuff, there will be subsystems that it can communicate through serial port communications, all the variables, and have the subsystem computer, like another cell phone computer, system on a chip. It could send it all the information to have it run scenarios, and maybe send that to 4 or 5 smartphones within the same humanoid robot. And then all those smartphones can report back their results and the outcome of scenario 1, scenario 2, scenario 3, etc. And then the main computer can choose whichever outcome it thought was best and then execute. So in that way, it can make really good decision makings and do the best thing at every time, in every situation. Even better than a human. Okay, so predicting objects' locations based on their speed. It will have to create actual scales of the value of life based on age, gender, socioeconomic status, or human and not human. So like if a car has to hit a raccoon or a small child, which should it choose? Well, obviously run over that raccoon. If it has to choose between running over a small poor child or Donald Trump's son, run over the small poor child, because Donald Trump's son is going to get you in more legal trouble if you run him over. He's pretty much world royalty. So basically it needs to determine things based on a combination of legal and moral considerations of who to kill. Or let's say it needs to run over Donald Trump himself or a group of 10 people. I guess kill the 10 people because he's the president? But that gets... I mean, that's a tough call. Even as the programmer, I got to really think about that. I mean, if I program a self-driving car that kills the president, I'm frickin' banned from AI for life. If I program a self-driving car that runs over a group of people, well, I mean, at least I'm not going to be thrown in Area 51 or Guantanamo Bay or whatever. I might have to face a trial. I'll probably not go to prison for that long. But if I kill the president, I'm freaking done. That's probably death penalty, even if it was just an errant AI that had to make a call. Although, I mean, maybe in a court case I could say the AI had to choose between killing 10 people or killing the president. It chose to kill less people. I don't know if the jury would say, yeah, but he's more important. I don't know. That's a really interesting philosophical question. I'm not sure. Uh, okay, so in robotics applications, we can use stereoscopic vision to gain depth perception clues of its environment, which helps a lot. We can use that for self-driving cars. We can use that for actual humanoid robots and animal robots. But in the case of a game bot or a bot that's trying to understand a game world to port it to VR, it's not going to have stereoscopic vision. So unless if it played the game with two characters that run side by side, two characters on two different accounts that run side by side through the 3D world, that would give you stereoscopic vision. You just have to always have two characters from two different perspectives, and those would represent the two eyes of a person looking from two different angles. So that's interesting. That'd be a cool way to get stereoscopic vision going. That's very interesting. I don't think anybody's ever thought of that as a way to port games to stereoscopic work, to work as stereoscopic games. But that's a really neat solution. Alright, another clue, very important for determining the distance of objects, and in knowing their distance, being able to estimate their size and their height, is when you move forward through a scene, those objects that are closest to you move out and back across your frame of view. Objects really far away get a little bit bigger, but they're not really moving out or side to side very much at all. So as you move through a scene, you can measure the movement of objects and get tremendous clues as to how close they are. Or in the case of an object that moves completely off your frame of view to the side, that would tell you I just passed that object. So not only are we close to it, I mean we're on top of it, we just moved past it. So that will help a lot. That's a great clue based on taking one frame, comparing it to another, as opposed to just looking at a static image. We still want the bot to be able to do a lot of understanding and guessing of distances and everything based upon being able to identify objects and have some guess as to what their size ought to be of the typical object that has a typical size. But sometimes you're looking at a giant, so you'd think they're closer, but they're actually far away. It's just a giant. So you need to know the difference. I didn't mention it in here, but there are other ways to get clues of how far away something is. Perhaps things like being fuzzy or foggy versus crisp. Something that's closer to you is probably going to look sharper and more detailed. Something really far away is going to look blurry. Maybe hazy due to atmospheric effects. So that's another great way. I didn't mention it in this document because I feel like that's going to be, well, that's doable. It's a hard way to do it, but I think it's doable. So we could also implement something like that. In fact, I should probably add that to this. Yeah, I'm going to add it. Wake up. Press semicolon. Note that we can also get a clue of object distance based upon an object being nearer to us being more crisp and clear and detailed versus objects further away being more blurry and faded due to atmospheric effects. Press semicolon. So determining object distances using atmospheric effects is a great way to get clues on depth perception. Stop listening. Alright, and by the way, I'll be coding all of this from the ground up, guys. This is not meant to be something where I just download OpenCV like an idiot and just use its algorithms. I can't speak on what bugs that will have, the huge learning curve without understanding. All I understand is how to tap into the API. I don't understand what's going on behind the scenes. To actually learn how all the algorithms work, read somebody else's code, it's like you could have spent that time making your own OpenCV. And that's my opinion. I'd rather understand what I'm looking at and be able to optimize accordingly because of my understanding. I'd rather have my own code and be able to identify bugs in my code accordingly, tapping into information that my vision system is creating to get answers to certain questions my bot might have. That information might be locked in a black box if I'm using OpenCV. So it's unacceptable to use third-party stuff when it's so vital of a system that you need to know what's going on in order to move forward, in order to create something as advanced as you need. You can't just use open source crap. And you never know with open source stuff if an update will get pushed that completely breaks your bot. And this can happen at any time. And now you need to start from the ground zero figuring out how to use the new update. Screw that. Less code maintenance if you run the updates intentionally rather than somebody just kind of screwing you over once in a while. Now you have to spend weeks figuring out how to get your bot working again. Screw that. Alright,